And I'm the lead developer of a platform that's used by several independent magazines that is written in Haskell. And I've been maintaining it for 4 years now, and well, 3 years. Before that, I was maintaining it. The actual application itself is from like 2013 or something, so it's like legacy Haskell. Fun stuff.
What's the name of the platform?
It's called Wayland. Let's see.
Sorry, I was just interested.
Yeah. I'm curious if I've got a. Does it have a website? I can't even remember. Anyway, it's called Wayland, and it's used by like Jacobin magazine, Dissent magazine, like lots of little magazines. So in this workshop, we're going to make a simple website using a web framework called FN, and we'll learn some Haskell along the way. And this is going to be a very introductory course, so I really want you to like ask questions if you aren't understanding anything, even if it seems basic or whatever. So I think hopefully everybody already got started getting everything installed, and definitely let me know if you run into any trouble with that. So in this section, we're going to start talking about how we can think about apps as functions. We're going to learn some things about the IO and maybe types. We're going to learn about type classes, and we're going to make a super simple text-only website. So all this database stuff we're not going to actually use yet, but we're just going to do that. So philosophical question, what is about? In Haskell, we like to think about it as a function, right? And we could think about it as a function from a request to a response. So it's a function that takes a request from the user or the client and returns a response, which is very like pure and simple and beautiful, right? So my first question is it possible to write a function like this? Any ideas?
It has to be.
Yeah. And there are libraries that give you a type that's called request that has all the information that would be in a web request, and that have like a type that represents a response that have all the information that would be in a web response. And you can write a function that turns one into the other. But my second question is, how would a web app that had this exact type signature be kind of limited? Any thoughts on that?
No side effects.
Yeah, any other thoughts on how it might be limited? If you had.
It might only return a website to a single user.
Threading would be if we want to put a worker on thing.
So that's interesting. I'll get back to that and to that. So what we're talking about is that a function like this is a pure function. The same request in, you're always going to get the same request out. If somebody asks for the index, that's always going to be the same no matter what. And you can't have any side effects. You can never like put anything into a database while you're processing a request. You can never read anything out of it. Your response is always going to be the same. Does that make sense? Okay. So one thing I wanted to address about like threading and stuff is that what you could do is you could have a pure function like this that is taking a request and putting out a response, and then give it to another function that actually sends the request or does threading or whatever. So you can have a function like this that does processing, and then some other function that actually sends, like talks to ports and stuff like that. So having a pure function in one place in your program doesn't mean that the whole thing has to be pure and do nothing but heat up your computer or whatever. So in the real our requests need to do a lot of things, right? So they need to like talk to databases, they need to read from the cache and put stuff in caches, they need to talk to the cloud. They need to have lots of side effects and do a lot of input-output processing, right? So how do we change the type of our function to accommodate all this stuff? Any ideas? So we want to change it from request to response to something else. Yeah, we're going to use I/O. Great. So quick on I/O. So what, all you folks who said I/O, what is I/O? What does that mean? What is I/O type? Yeah. What does the I/O type let you do?
Side effects.
Side effects, yes.
Horrible real world.
Yeah, the horrible real world. So, I mean, that also answers the second question about why it's useful. Lets you interact with the real world, right? So, my next question is how do you, but actually I'm just going to answer that. So here's an example of an I/O. So we have a function called getLine that what it does is it returns in, I guess. And you can see from the type that it returns I/O of text. So it returns text in this context, something that can do side effects. Reading from,
Your microphone went full stop.
oh, oops. Maybe I should have asked for help with that. Okay? Maybe I'll hold it. So
have it a little bit higher.
higher.
Okay. Yeah.
Okay. Does that sound okay?
Yeah.
Okay, great. So we have this function that is of type I/O text. So it does some side effect and returns some text. And we can put it on this side, on the right side of this little arrow here inside of do notation. And it'll run that computation and return something that we're going to bind to a name on the left side. Then we can use it in another I/O function, or whatever we want to use it in. Does that make sense, or enough of a gloss on what it means to move on? Okay. So the type that we're going to actually use in our real-world applications is this type. It's an app has a type of some request context. So this means that we're going to have a type class called request context, and we're going to take anything that's an instance of that type class. So it takes a request that's in some context, it can do stuff or not, and return a response. Does that make sense? How this is a more complete type than before? Okay, or more complete for what we want to do. So what is the FN web framework? FN gives you tools for defining the application state, parsing, routing it, handler, constructing a response, and interfacing with some other common web application libraries. So you may be wondering, like, why FN? Not like there's tons of other web frameworks that are amazing. And the answer that is honest is that I really like FN. It's what I want to teach. But I'll also give you like real reasons. It's simple, it's easy to use. There's not any template Haskell. You need like extensions, which is pretty unique. And the way that the routes work is really cool. And I'm going to talk a little bit about that either today or tomorrow. So when we're talking about our request context here, that's kind of representing the application state, how to access application state. So, and there's lots of things that you might keep around whenever you're processing a request. You want to have the request itself, obviously, but you might also want like a pool of database connections, the cache. You might want like configuration variables, what environment you're operating in, if it's development or production or whatever. And then since we're just like passing in a parameter, whenever you're in your handler, you can just say, okay, get the database out of the context and let's use it. So that's kind of how FN lets you use the request context. And we'll go into more detail here. So if you open up in your, so I'm going to show you how to do this. So if you go to your terminal and you type stack dhci in your project, you'll probably see something like this where it says that is ambiguous. Just type 2, and that'll open the main one. Is that working for everybody? Okay, cool. And then you can type start, and that start a little app. And then if you go to localhost 8000, you should see some text. Beautiful. Is that working for everybody? Cool. Yeah, so yeah, so you want to do stack dhci to start dhci, and then start. Well, actually, import first site, start, whatever. So if you open up source/first site, then you'll see the actual code for this application. So what I'd like you to do is to make your own context for an app. And you can make whatever data type you want with whatever fields you want. And it can be like real fields that you would actually want in a request, or they can be like silly things like whether you like pizza or not. Just want to try out like how do you make a data type in case anybody needs a refresher on that. Yeah, the only that you need to have in there is some FN request.
Is it some convention by school?
Yep. Yeah, this is just for FN.
And you can recognize both, basically. You just in context that you have it. So you have context FN request.
Well, nope, we're going to write a type class instance for it. Okay, does everybody have their data type ready? Anybody need more time? Okay. So, like you said, FN needs to be able to access the request from that type. If we can make our type whatever we want, how does it know how to get the request? And there are a lot of fancy ways that FN could be doing this. Like there could be, I don't know, advanced stuff going, but what we're actually going to do is make a type class. So again, I don't want to assume that you all know how to make something an instance of a type class. So just a quick refresher. If you need a refresher, just open up the typeclasses.hs, and you'll see a couple of data types. And if you don't have a type class instance for show, when you try to print some value of a type, it's going to be like, I don't know how to do that, right? And if you look at the type of print, it says this needs to be an instance of the show type class. That's what this part means. And there's one way we could do that, which is just doing deriving show. And GHC will just figure out how to represent your type. So if we put deriving show on both of these types, then it'll just figure out how to do it. And it'll print it in a way that is okay. The other thing you can do is you can write your own instance of the type class. So we say instance show character, and then we tell it how to make it an instance. And if we do that, we can make it show it however we want. We can make it look really pretty or whatever. So does that make sense to everybody? Okay. So this is the type class that we're going to use for FN. So if you go to Haskell.com, there's a link up in the top to the hackage documentation. And that's probably like the easiest way to get to it. Also drop a link in the Discord. Oh, whoops, did I go over? Oh, no. Okay. So it's in the documentation that there's a couple ways that you can instantiate this type class, or a type to be this type class. So you can define a lens, which you can like look at that type and you can be like, that's really weird, I don't want to touch that. Okay. I'm not going to teach you how to use lens. We can let Edward do that. Instead, we can implement get request and set request, because those are a little bit, they don't require any dependencies or anything. So here's how to do it with a couple really simple examples. So if you've made a new type for your web app, go ahead and also make it a instance of this type class. And let me know when you're ready. Is anybody having any trouble or have any questions about how this works?
I had a question about the syntax.
Sure.
The property set, I guess that's context and then request equals new request.
Sure. So this means that you put your whole type or value over here, and then this is the name of the field, and then the new value.
Okay, and it uses all the previous fields.
Oh yeah. Yep.
Okay, cool.
Any other questions? Do folks need more time?
Do you have to do this for every request you define, or is there some
You-
easier way so you don't have to write so much boilerplate?
For this is just you usually only have one for your application, so you write it once and you're done, and then just add, my web app's like request context is has like a bazillion fields at this point. Keep adding to it if you discover that you need need to be able to access new properties. So we use it a lot at work because that is same code base, same backend code base. So, but each magazine is very different, right? They have different front ends, different different prices, shipping costs, all that stuff. So that all gets stored in the context. And then whenever we're, processing a new subscription, we just say, okay, what's the subscription price from the context? That's how it's very handy. Any other questions? Yeah?
When we want to make our type and instance of request context, the syntax is instance name of our type request context where?
Instance, the name of the type class of the class, the request context, and then your type, and then define functions that the type class tells you to define. So if we look back at the documentation here, what this is saying is that you need to define. Well, it's saying that the type class has these methods. And then the documentation up at the top says which ones you need to define. And then they just give you a type. And as long as you define something of that type, it should work. Uh-huh.
So is this context effectively passed through layer?
Exactly.
Does it effectively grow as the scenarios of an application grow? Is there a way to keep it contained? Is it in the scope of the workshop at all?
Not really. I'd love to know the answers to those questions. Yeah. Any other, anybody having any trouble with the instance, making an instance? Everybody ready to continue? Cool. So FN uses WAI, which is a library that gives you a lot of nice tools for web apps. It has a lot of nice middleware, so if you need logging, static stuff, you need to add sessions, there's a WAI library for that. And then Warp is our actual server, which is going to send the requests and receive requests, or send responses and receive requests. So the way that we interface with those is a few functions that F provides. And you can see these in the first site.hs. So run is from Warp, and it takes a port number and something called an application. and it returns IO, because it's very side affecting. To build our thing that's a type of application, we're going to use toWai from FN, which it takes some request context and a function from a request context to a response, to an IO response, and it returns an application. So it turns some function that you write and your context into the thing that the server wants. So the thing that we're going to write is this cite function, which has the same type as the one that I showed you earlier, a request context to IO of response. Everybody still with me? Cool. So this is what that looks like. So I'm going to go really deep into this in a minute, but basically we have this function called route that routes the request through a bunch of patterns, a bunch of functions that go from a pattern that your request might have to a handler. And then it can fall through to a page not found response. Or it could fall through to an error response, fall through to any response if you wanted. And then we can handlers, and all of our handlers typically have, they take a context and eventually return an IO of maybe response. If they don't take any parameters or anything, then it's just context to IO of maybe response. And OK text here is a helper that gives you to return some 200 OK response that's text. Does this make a little bit of sense? Because all of these things we're going to go into more detail of, but cool. So if you open up First Site, it looks something like this, and it's an entire, it's a website. Cool.
What is end, the function end?
Sorry?
The function end there before the error. In the route.
In the route.
And then arrow index.
Oh, yes. OK. I'm supposed to show things on this screen. So this is a custom operator.
No, but the function before that?
Oh, end. That is a pattern. So that's saying that the only pattern that this matches is just the end of the request.
Okay.
I mean, it's a little bit weird, but like, it makes more sense if you think about it being like, I want one pattern to match just hello, and I want another pattern to match hello name, right? You could say hello end, and that would not catch the other one. And any other that jump out at people?
Where is it defined?
That's from FN. Yeah, FN gives you all the routing pattern functions. Anything else? Okay. So again, fnhaskell.com has all the docs, and so let's go like a little bit deeper into how these routing functions work, or well, how to use them anyway. So the way that the routes are structured is you have a list of them, and each one has two parts. On the left side, you have some pattern that maybe matches a request. And on the other side, we have a handler that maybe handles that pattern of request. So, and then if both those sides, or either of those sides fail, it just falls down to the next one and just keeps going. And then it just falls through and then returns whatever is your fall through response. So here's some of the patterns. There's end, There's path, which is just like /blah. You can match on methods, get, post, whatever. There's anything, which matches anything. And then there's two patterns that will actually pass parameters to handlers. So the segment pattern would say, if you say hello party, it would pass party to the handler. And I'll show you what this looks like in a second. And then there's param blah, which would, if you said hello blah equals foo, would pass foo to the handler. So here's what that looks like. So segment that is type text, and that text is passed to the handler, which can use it in the response. So I'm going to start up the other app. Oops, not LO. Well, there you can see the not found response. So that's what it looks like. So there's this // operator that you can use to combine the patterns together.
So n matches just in slash.
So if you didn't have that there, if you said like anything, if you use the anything pattern instead, then index h would have caught that request. Anything else jumping out at people? Okay. So we can also use param, and that's using the param pattern. Looks exactly the same. I guess I'll say there you can see that's different. And you can see that, I mean, it looks exactly the same, and it turns out that you can just use exactly the same handler for both of these patterns because they have the same type.
Did you start the second site?
How did
You started the second site, the second server.
Oh, yes. Sorry, it's main. If you type in main in GHC, I mean, you should get the main server that has all the examples in it. First site, I just wanted to have a module where you can like throw stuff in there. And that didn't require the database to be set up. Yeah. So it matches hello party and hello name equals party. One thing that you might have a question about is this maybe type. Is anybody here unfamiliar with the maybe type? Everybody? Okay, so I'm going to go over maybe type. So maybe is a data type that is a sum type. So it can have two different sort of values. So you're often using this for like, if you don't know, I'll go into that later. So maybe A can be like maybe anything. So it can be just A or it can be nothing. So if it's maybe a string, then it can be just a string or it can be nothing. If it's maybe an integer, it can be just an integer or nothing. So that lets you kind of capture that some functions don't have like there's not, sometimes you don't have a value. So like head of an empty list is the common example. What is the first element of an empty list? It just blows up. But if you say list to maybe instead of head, it'll give you just just the first element, or if the list is empty, it'll give you nothing. Does that help? Okay. So we can use the fact that it's a maybe to give, to let the requests kind of fall through on purpose. So not just if the pattern doesn't match, the handler can decide not to handle. So if I say, hello, Libby, it answers an So just do that by, instead of returning using the OK text or OK HTML or other helper given by FN, we just do return nothing, and that returns not a response. Is that it? Does that one make sense? Okay. Cool. So another cool thing about FN is that it is all the right routes typed, and if a handler doesn't match the type of the pattern, then it handles it differently. We have two routes that are the same, that look like they're the same pattern, but their handlers are different, and their handlers have different types. So if I go to this server and I say 1, 2 as my segments, whoops, I need to say add. Then they're added together like numbers. But if I put in strings as my, then they're added together like strings, because these are different handlers based on them being different types. So the types of the handler arguments are the types of the pattern segments. Does that, now that part is a little bit wild, so everybody still with me? So what we end up with is a list of routes, and the routes they seem to be very different, right? So we have one route that doesn't take any arguments. We have another route that takes one text argument. We have another route that takes 2 integer arguments, and another that takes 2 text arguments. So they seem very different, but they're a list, and we know that in Haskell all the elements of the list must be the same. So all of these must be the same type. Just want to end this session on a bit of a mixed mystery, like how does this work? And I'll come back to that in the next session.